Let's have a look at worksheet number 2, question number 9, the one that relates to force versus time graphs. If you remember, on Friday we took a look at these force versus time graphs. You should remember, I hope, that whenever we see one of these force versus time graphs, we should automatically think 3 words. What are those 3 words? Right away. It should be automatic. What are they, Evan? Area equals impulse. Now, we got to pay attention to all kinds of things, but the first thing that we think of is just automatic. Area equals impulse. What do we want to check here beyond recognizing that area is equal to the impulse? We want to do this for every graph that we see, not just force versus time graphs. Yep. Yeah, check your scale. Here, check your scale, but also check the units on the axes, right? When I look at this, I see newtons and I see seconds, which are standard units, which is good. That means I don't have to deal with it in terms of converting or anything like that. If it was kilonewtons, then you just multiply all your numbers by 1,000. If it was millinewtons, then you just divide all your numbers by 1,000. That's all. It's not crazy hard to do. You just got to watch it, pay attention to that, and recognize that you got to do something with it. All right. I don't even know what I'm not even paying attention to what I'm being asked for yet. I recognize that this is a force versus time graph. I'm going to do area equals impulse. Let's find it. The area equals the impulse, and this is a triangle, so I'm going to say 1/2 base times height is my area. What's the base? Goes from 0 to 10. What's the height? Goes from 0 to 4. 1/2 of 10 times 4 is 20. Wait a second, don't I have to do this and break it into 2 triangles like this? 1/2 base times height plus 1/2 base times height. Can I do that? Sure. How many of you did that? Most of you did. I know you did because I was walking around on Thursday when you were doing it. Most of you did. You just doubled the work though. It's okay. It's right. But you don't have to have a right angle triangle to use 1/2 base times height. Any triangle works for that. So you should have gotten 20. I got 20. We're always going to get the same number that way. All right, what am I looking for? The object's change in velocity. If I was looking for impulse, I'm done. But I'm not. I'm looking for change in velocity. So what else can I do here besides what I just did? What else can I do? Yeah.
Get the equation.
What equation? Good. M times delta V. Don't use what? Do not use ever in this context what? Force times time. Don't use that. The force is changing. Don't try to use that. I'm going to give you a question probably tomorrow or the next day as a little review question. You are so going to be tempted to use F times T. I'm telling you right now, don't use F times T. Okay, you're allowed to use M times delta V, not F times T. Let's calculate delta V here now? Delta P over M. What's delta P? 20. We just found it. And we didn't have to really think about that because we just automatically found it, right? That's just what we do every time we get one of these graphs. The mass is 4 kilograms. 20 divided by 4 is 5.0 meters per second. What's the change in velocity? 5.0. Sometimes they ask you for the change in velocity. Sometimes they ask you for the final velocity. If the initial velocity was 0, then the final is the same as delta, right? If the initial velocity was 6, what would the final be here? If it started at 6 meters per second, VF would be, this isn't hard. If VI is 6, then what would VF be, given that the change is 5? The initial is 6, we changed by 5, the final is 11. Yeah, the final would be 11 meters per second. So what we do, right? Looking for the final, just add your change, which I just got, onto my initial to get your final. Got it? All right, I want to take a quick look, just a very, very quick look at our Physics 30 and 13 pages document, page 2. We've already gone through topic 12. I want to just look at a couple things with topic 13 and 14. We've gone through this whole thing now, but just to make sure that you guys understand what I mean by all these little blurbs here. I've said possible physics principles, accelerated motion. We actually used another one in our practice question set number 2. Remember what one we used besides principle 1? You used principle 1, right? What did I use? Yeah, I used principle 3, the work energy theorem. That's the one that I used. So it is possible to have that one there as well. Definition of impulse, we know that, right? A change in momentum, Newton seconds or kilograms meters per second. The equation, I say both parts, there's really 3 parts, right? Delta P, F times delta T, and M times delta V. 3 parts. Be able to rearrange it and so on. What do we mean by D? Predetermined impulse. Predetermined impulse is when an object is stopping. And remember, the idea is usually decrease the time to increase the time, right? You don't want to decrease the time. You are a terrible engineer if you're trying to cushion impact by decreasing the time. You could not be more wrong. We want to increase the time and therefore decrease the force. Versus when we have a non-predetermined impulse, we're starting an object, not necessarily from rest, right? Baseball's coming towards you, you're going to start it moving in the opposite direction. Here, you want to increase the time, but that doesn't affect the force. That affects the impulse. You also want to usually increase the force, which also affects the impulse. The vector nature of it, there's a direction associated with it, right? And positive, negative. Remember, it's a positive impulse when you're increasing momentum in the positive direction or decreasing momentum in the negative direction. Right? Significance of positive and negative. We already have this, I guess, equation and rearrange. And then the force versus time graphs. What do we got to remember? 3 words, right? Area equals impulse. Pay attention to the units on the axes. Okay, we focused on that, right? When we see a graph, a force versus time graph, always want to be newtons and seconds. If it's not, that's fine. Just convert it. Okay? Do your work in newtons and seconds. So find the change in velocity, final initial velocity of the mass. All that means is, look, set the area equal to the impulse that you found, and then use m times delta v and solve for either this or this. What does this mean? Above or below axis. The question that we just did for homework didn't involve D, but we talked about this. If it's above the axis, it's a positive impulse, yeah. And if it's below the x-axis, it's a negative impulse. Good.